My name is Vinit Ram. I'm branch regular. My roll number is 220150207. Today, my topic for this presentation is energy sources, energy systems, and resources. I'm going to discuss about the conventional type sources of energy and non-conventional sources of energy. I'm going to compare those, and I'm going to discuss which one is better and which one is we are using currently. So, as we can see, there are mainly two types of energy sources. First one is the conventional, second one is the non-conventional sources of energy. So, in this presentation, I'm going to examine the challenges and opportunities associated with each source of energy, and to check the potential of the emerging technologies such as renewable energy, solar, and wind energy. From a global point of view, there are mainly three topics to be considered. First one is the energy demand, second one is the energy sources, and third one is the energy security. The energy demand, as we know, is growing rapidly from every day based on the population. Since the population is growing day by day, the demand for energy is rapidly increasing. So to meet this demand, we need to increase the available energy sources, either by using conventional source of energy or non-conventional source of energy. But the disadvantage of using conventional source is that it is in limited quantity and it causes pollution to the air and damages the environment around us. So the main focus of this PPT is to focus on other sources of energy that we can use to reduce the dependence on fossil fuels and conventional sources, and to increase the health of the climate as well as to meet the energy demands. Energy security is nothing but to provide reliable and affordable energy to everyone in a society. As we know, there are mainly two or three points in energy distribution. First one is the equal supply to everyone. If there's any inequality in energy supply, it will cause a huge disparity in the society. So to ensure that this does not happen, we need to ensure equal distribution of energy to both lower class and upper class of the society. So this is the fossil fuel. The main sources of fossil fuel are coal, oil, and natural gas. Coal is nothing but, as we know, the major source that we are using nowadays is coal. About 80% of the energy needs in today's day and age are being met by users of coal. Oil is nothing but it is essential for transportation and fuels. Oil is obtained by extraction processes, which require huge capital investment and also which causes heavy pollution. Natural gas, it is also a form of conventional source. It also causes pollution, but also provides high source of energy. So these three are the major sources of energy in today's age, which provide high energy, but also cause heavy impact on society. Next, the renewable energy sources are solar, wind, hydro, and geothermal. These are the main sources of energy that are being used nowadays, and which are becoming more and more popular as the time passes. The main advantage of them is there is no pollution in this. There is no pollution due to these sources of energy, and these can be used to meet the growing energy demand. Solar is nothing but harnessing sunlight from obtained from sun to convert that sunlight into electrical energy and to be used to supply the loads. Wind energy is nothing but using the kinetic energy of wind to convert it into electrical energy and supply loads. Hydropower is using the potential energy of water and the kinetic energy of the water by placing the turbines in the runoff of the water. For example, if there's a flowing river, if you place a turbine in that river, the natural flow of the water helps in rotating the turbine. So, hence, there's no pollution, and this aids in the generation of electricity. Another one is geothermal energy. Geothermal energy is nothing but the heat of the earth. As we know, heat on the earth is not a conventional, not a limited source of energy. This is there throughout the year. Maybe the location changes, but it is available throughout the year in the entire earth. So this heat can be used to convert the heat energy into electrical energy. These are few of the types of renewable energy that are growing in popularity because of their advantages. Another one is nuclear energy. Nuclear energy is a growing energy. Like the popularity of nuclear energy is very rapidly growing because of the benefits that it produces. In nuclear energy, there is no pollution, but there is a hazard of nuclear waste that can be disposed. The benefits are low carbon electricity generation because of no combustion of fuels and no combustion of coal. There is zero or low carbon emissions. Hence, there is zero carbon electricity generation, and there is high energy output. Since we know the nuclear reactions produce very high amount of energy, this causes very high energy output. These are very reliable since nuclear reactions are in our control. Like we can initiate the nuclear reaction. That means we have the control over the amount of energy that we need to produce. There is potential risks associated with this is nuclear explosions, nuclear radioactive waste, and other associated hazards are associated with this nuclear energy. Hence, the usage of this is can be done based on the permissions that we get from the government and based on the acceptance of people. Next, the waste management. In other sources of energy, waste management kind of takes a backseat because the main goal of that is to generate energy, and the hazards caused by this waste is lower. But when it comes to nuclear energy, the waste that is being disposed is radioactive in nature, and this might cause the very hazardous effect to the flora and fauna of this land. So the waste management needs to be taken care of in a very systematic order in order to reduce the impacts on the environment and to increase the energy efficiency. Next one is the energy storage. We've discussed about the energy sources of energy, how we can produce energy, what is the difference between renewable and non-renewable. But if we can't store an energy, then we have to continuously depend on the active generation of energy. For example, if we have a renewable energy like solar, we cannot depend on it throughout the day, right? In the daytime, it will generate energy, but at the night, we need something to store the energy that is being generated at the day. So here comes the energy storage solutions. There are three types of solutions that we're going to discuss. First one is batteries, pumped hydro, and compressed air. As batteries, we all know batteries that are already in our phones, batteries that we are using in everyday life. Here, the energy stored in chemical form. The chemical energy is converted into electrical energy that we are using for our loads. Next, pumped hydro system is nothing but pumping the water uphill to store energy and releasing it to generate electricity on demand. As we've discussed in hydropower, the kinetic energy of water is being converted into electrical energy. The pumped storage is nothing but after converting it into electrical energy, we are again pumping that water back to the head of the storage system, so that we can use that again to generate electricity. In compressed air, storing energy by compressing air underground and releasing it to drive turbines. As we know, the main principle of any energy generation is to rotate the turbine using some form of energy. In this compressed air, the compressed air is used to rotate the turbine, which in turn is coupled to the generator. But this air, after rotating the turbine, is again captured and compressed in the underground systems. This air is continuously cycled to rotate the turbine. This is very efficient since the air is not lost, as well as there is no pollution associated with this. Next one is smart grid, enhancing efficiency and reliability. Now we know that there's generation, there's storage, and then we need to also have transmission and distribution system, right? So in this, the smart grid comes into play. Here we can have four key features. First one is the real-time monitoring, demand response, integration of renewables, and improved reliability. Real-time monitoring is nothing but we need to monitor the energy consumption, the generation, and grid performance. If we know the consumption and we don't know the generation, there's a mismatch between the load and the supply, right? So we need to match both the load and supply. Hence, we need to real time, like monitor the demand and supply in real time. Next one is demand response, adjusting energy usage pattern to balance supply and demand. As we know, the demand does not stay consistent throughout the day and not necessarily throughout the year. So based on the cycle of the demand, whenever the demand is in high, like whenever there's a peak demand, we need to increase our generation to a peak. Whenever there is low demand, we can reduce our generation. So this adaptive nature should be available in our smart grid. Next one is integration of renewables. Nowadays, the main source of energy, our main generation is, as we discussed, is conventional sources. Like we are using coal to burn and to rotate the turbine. So integration of renewables is nothing but the renewable energy sources that we have, solar, wind, nuclear, and other sources. that we need to integrate in the existing generation in order to reduce the carbon utilization and pollution to the environment. Next one is improved reliability, enhance the grid resilience and faster response to outages. For example, there's an outage near your home. The response time that takes it nowadays is very high. You have to call the lineman, you have to call him physically, and he'll analyze the problem and he'll do a solution. In smart grids, the main focus is to reduce the dependence on human personnel and to optimize it such a way that there's an automatic detection of any fault occurring at the exact spot location. So based on this, we can provide an instant fix and improve the reliability of the supply. Next, energy conservation and efficiency measures. Here, the main focus of this is to utilize the energy to maximum potential. As we know, energy consumption, like energy production, is mainly dependent on energy consumption. If energy is consumed efficiently, the energy production requirement will be reduced. So here, what we can do is we can mainly focus on four different steps: energy audits, smart appliances, building retrofits, and behavioral changes. Energy audits, identifying areas of energy waste and recommending improvement. For example, if in your home the power factor is less than 0.9 or less than 0.85, you can suggest improvements such as using capacitors and other devices to improve the power factor, which will enhance the usage of energy. Similar things can be done in industries and in different areas to improve the energy utilization. Second one is the smart appliances. Using energy efficient appliances. For example, if someone is using an incandescent lamp, which is burning as compared to an LED, you can suggest that you should use an LED. These are simple tips, but this can be applied to mass scale in different industries also. So that will account to a larger amount of saving in energy. Next one is building retrofits. Insulation, window upgrades, and ventilation systems to reduce energy consumption. As you know, a lot of energy is lost in heat, in the form of heat and like heat energy. So to reduce this, we can use insulation, proper ventilation through windows. Proper cooling system is required to reduce the heating and reduce the heat losses. Next one is behavioral changes, promoting energy saving practices in homes and businesses. If in homes people are made aware of the importance of energy conservation, then they will change their patterns and adapt to saving more energy and utilizing the energy to its maximum efficiency. For example, adopting different practices such as turning off the fan when you're not in the room. These might be small steps, but these all add up to a greater energy conservation. Next, the future of energy. The future of energy that I see is mainly of three types. First one is the fusion energy, energy storage advancements, and artificial intelligence. Fusion energy is harnessing energy from nuclear fusion, a potentially limitless clean energy sources. As we know, nowadays nuclear reaction that using a nuclear fission reaction to produce the energy. But nuclear fusion, as we know, requires a lot of constraints, and it is very hard to cause a nuclear fusion reaction. But if we can scientifically achieve that, then we will have a limitless source of energy at our disposal. This might be possible in the future, since nowadays now there's not enough technology to achieve this. Next one is energy storage advancements, development of high capacity, low cost battery technologies and other innovative storage solutions. Nowadays, the battery efficiencies are quite low and the cost is quite high. In future, this will be opposite. The efficiency of the batteries will be very high and the cost associated with it will be very low. Next one is artificial intelligence. Artificial intelligence is nothing but optimizing the energy grids, predicting the demand and improving renewable energy integration. As you know, using artificial intelligence, we can predict something. There's supervised learning and there's unsupervised learning. In supervised learning, based on the data that we give in and based on the labels that we provide, it will cause a prediction. In unsupervised learning, we don't give any labels, but we only feed it with data. So based on this data, it will classify the data into different categories. So we can use both of these types of learning to our advantage. First one is a supervised learning. In supervised learning, we can provide the past record of the data, history of energy consumption, and history of the energy generation. So based on this, the model that is being trained on this data will will predict an outcome. Will predict the energy demand that may be associated now. and will also give the energy generation required to meet this as a particular associated demand. Also, we can use unsupervised learning to predict these parameters in an unfamiliar environment. For example, if we don't have any data associated with it, or we don't have any particular label data for which source is requiring more amount of energy, which source is requiring less amount of energy. So we can use unsupervised learning in that case to classify the sources or classify the loads that require high energy as one class, and the loads that require low energy as one class. So based on this, we can optimize our generation and distribution. So conclusion, by embracing sustainable energy practices, we can build a more resilient, equitable and environmentally responsible future. The transition to cleaner energy systems is a global challenge that requires innovation, collaboration and shared commitment to sustainable future. As we know, the main focus of any energy sources in this day is to transition from conventional energy source to non-conventional energy sources because of the advantages associated with this renewable sources of energy. But the main challenge is to overcome the limitations that this offers. So we need to overcome these limitations by advancing in technologies and to achieve high efficient energy systems. Thank you.